Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you'll get everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And are you struggling to keep up with customer requests and letting errors slip into production? Want to try some of the innovative ideas in this podcast but don't have time? Data Kitchen's Data Ops software allows your team to quickly iterate and deploy pipelines of code, models, and datasets while improving quality. Unlike a patchwork of manual operations, Data Kitchen makes your team shine by providing an end-to-end data ops solution with minimal programming that uses the tools you love. Join the data ops movement today and sign up for the newsletter at datakitchen.io/DE. After that, learn more about why you should be doing data ops by listening to the head chef in the Data Kitchen at dataengineeringpodcast.com/datakitchen. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Kevin Doran and Andy LoPresto about Apache NiFi. So, Kevin, could you start by introducing yourself?
Sure. My name's Kevin Doran. I'm a committer on the Apache NiFi project. It just means that I submit contributions to it, and I help review other people's contributions to the project. I've been doing that for about a year. I'm also a software engineer at Hortonworks, which is one of the vendors for Apache NiFi. They've got a product called Hortonworks Dataflow, which is basically NiFi but comes with enterprise support. I'm on Hortonworks on the Dataflow management team, which means I contribute to products like Apache NiFi.
It's always nice being able to get paid to do open source. And Andy, how about yourself?
Hi, I'm Andy LoPresto. Like Kevin, I'm a committer on the Apache NiFi project. I'm also a member of the PMC, which is the Project Management Committee. So members of the PMC make decisions about the future of the project. We can cast binding votes on releases, and we perform a couple other housekeeping tasks. I'm a senior member of technical staff at Hortonworks, so like Kevin, I get paid to work on open source software, and I'm on the core engineering team, so get to work on NiFi every day. I focus on information security, and that includes cryptographic services, data protection, threat modeling, and vulnerability assessments and mitigations. And in the past, I worked for Apple and some healthcare-focused startups.
And Kevin, again, do you remember how you first got involved in the area of data management?
Kind of indirectly, like without really knowledge of what I was doing. So out of college, I was doing research and working in the areas of networking protocols and cybersecurity. So not directly like data analytics, but we were working with a lot of data, and it was in formats like CSV, XML, JSON. So just out of necessity, we would write scripts to deal with these large data sets, things like Perl and later Python to manipulate the data. So just sort of scripting some jobs around structured data to process it. And that works for a while, but over time, those research projects, they keep going and new requirements get added to them. You're looking to other areas, you have new data sets. So those, it starts as a couple simple scripts, they grow, you get new requirements like how do you process and deal with binary data? How do you do continuous processing or batch jobs when data we were collecting would get input into the system or other partners would send us big data sets that we'd have to process. So, while we're doing research and we've got the domain we're focusing on, there's also like this huge data problem and data management problem that we have to deal with. So it turns out that was taking up a lot of the time as the actual research domain work. So that was like a good introduction to, I guess, the wrong way to do data management because we made a lot of mistakes, but it was a good learning experience. Later on, a little bit later in my career, I was working actually at an advertising optimization platform for online advertising. And it was the first time I was exposed to what we'd call like internet scale data. So billions of records per day, continuously flowing, being fed to various processing chains, feeding algorithms, feeding models, data coming in to enrich our data from third parties, our data going out and packaged, delivered to partners. So constant everyday data management problems. And so that was a really good learning experience for some more advanced data management frameworks, data storage tools, data archiving policies, and connecting decoupled systems that need to share data and interact with each other. And that's where I really started to understand like some unique aspects of data engineering and data management.
And Andy, do you remember how you first got involved in the area of data management?
Yeah, I've actually worked on data management for most of my career, which I did not intend to do either. I started by writing these internal management systems for a startup when I was an intern in high school. And that was things like an asset management database and a document management database and an applicant tracking system, just because they were small and didn't have anybody else to do that. And from there, I went on to, I don't know if you're familiar with Documentum. This was these like workflow and lifecycle software tools, and then started building out applications and APIs that were doing metrics tracking and analysis. And finally, when I went to Apple, I was actually working on information protection across the worldwide retail stores. So throughout the world, all the financial data and tracking information and customer information. So it was really sensitive stuff. And like Kevin said, that was kind of my first time seeing that kind of data on that scale. So that was my introduction to data management.
And as I mentioned at the opening, we're here to focus on the work that you're both doing with the NiFi project at the Apache Software Foundation. So can you start by explaining a bit about what NiFi is for anybody who might not have heard about it yet?
Andy, you want to take this one first?
Yeah, thanks, Kev. NiFi is a data flow tool, and that is a very simple sentence, but data flow means different things to a lot of different people. And so the analogy that we like to use is that consider data like water. NiFi is not here to help you build these complicated sewer pipes where you have to design it and then you construct it and then test it, and it's a giant system, and then you like flip a switch and turn the data on. Data is always flowing, it's always there. So NiFi lets you dig an irrigation ditch off of a river. And so you see data flowing in real time, and you can interact with that and expand the ditch, add another one in a different direction, plug one up. You see what's happening with real data as it's flowing. So all that monitoring and feedback comes from the original demand for NiFi. And NiFi was initially conceived of at the U.S. National Security Agency by Joe Witt, because he was encountering a lot of these brittle data movement systems across the organization. And Kevin mentioned that in his experience as well, all these little scripts and things like that. The data is mission critical, but all these moving parts, a lot of it wasn't repeatable or resilient in the face of disruption. So if there's a connection that goes down at 3 a.m, you probably don't have a software engineer on standby to write code to change the destination of a stream, or you don't have a Perl expert who can look at 100 parentheses and semicolons and figure out what needs to change in that second. So these giant operation centers, like if you remember the show 24, like all the screens on the wall and people on these tiered platforms and throwing things to different screens, like you need to keep the data moving at that time. So these people who are not software developers, not coders, but were operations people, needed to have a tool where they could take immediate action and keep the data flowing and be able to see the problems as it happened, or ideally even before it happened. So NiFi matured for quite a bit, a number of years inside the organization, and then it spread to a bunch of different teams. And in 2014, the agency released NiFi to the Apache Software Foundation through their technology transfer program. And so it's continued to grow with a number of contributors in the open source world, and probably more than it ever would have been able to inside the organization.
And you mentioned that the primary purpose of NiFi is for being able to, as you put it, build these irrigation ditches and then redistribute the water flow as it starts working its way through the system, and being able to evaluate in real time and very reactively how the data is flowing and modify it while it's in flight. And is the intent to, in the general case, eventually codify some of those data flows with some more robust systems, in your case, the sewer pipe analogy?
So that's certainly an option. What we have found, I think, through a number of different users or customers, is that some organizations like that reactive and ever-evolving model, and being able to receive feedback immediately and have this very tight life cycle developing their flows. Other organizations very much prefer the more traditional approach of building something, deploying it, and having it stay constant until an intentional change is made. And so I'm not going to say it's a one-to-one match, but it is similar to like agile workflow versus waterfall software development lifecycle. And a lot of organizations that are deploying NiFi into production environments and have these flows have rules and whether it's externally regulatory or their own internal rules and systems about how things in production can change. And so they have these approval processes, and you need to get sign off from a certain team, and change can only happen at a certain time and things like that, and very restrictive access control for the production system so that a user isn't changing a flow while it's deployed live in production. So we've seen that kind of the demand for that grow quite a bit in the open source world, even being deployed to private organizations. So that, I think, is more along the lines of what you're asking about, codifying these into more rigid, perpetual data flows.
The one thing I would add to that is that NiFi, it's really good in an environment where you have changing requirements. So when you do have a data flow that is codified in some other form, it's great until the data changes or the requirement. And so then, where NiFi's strength at the beginning is getting started and building a data flow out very quickly and visually, it's also its strength when it comes time to modify a data flow to reflect the data or the requirements of change.
That's a great point, Kev.
Yeah, that's definitely one of the areas that comes up a lot in conversations that I've been having, is that as you build these very robust and structured systems that are intended to be sort of industrial strength and able to process massive amounts of data, is that data, as everyone knows, is very messy and potentially changing. And if you don't control the source of the data, then you can potentially be surprised by having maybe some format of it modified, or adding a field or removing a field that all of a sudden breaks all of your assumptions, and thereby requiring a lot of upfront investment in terms of alerting and monitoring and testing of the data as it hits these various transition points through these different systems.
Yeah, exactly. And that's kind of the motivation for why NiFi went with a web UI for actually defining and authoring the data flow. As Andy mentioned, one reason was that it was designed to be a system that could be used by non-programmers, by operations folks who might be very good at managing data and understanding it, but just don't have a background in traditional software programming. But that's, to make it a tool for designing and implementing a data flow visually and graphically, it's also its strength when it comes to going back to a flow that's been running for 6 months and making a change to it. For one, it's very quick to remember what it was doing in the first place if you haven't seen it for a while, because it's visual and you have those visual cues and descriptions as to what's going on. And then, also when you're making a change, it's through a UI, it's easier to understand and reason about. You've got, arrows and connections showing how one thing goes to another thing. You don't have to, trace code through an IDE. So it's designed to solve that problem in an environment where you need to be reactive or agile, and you expect your flow to change over time. So the interface to NiFi reflects that design goal.
And how did you each get involved in the project?
Kev, you want to go first?
Sure. Andy kind of roped me into it. I mean, that's true and not true. I started hearing more and more about this project called Apache NiFi. Probably this was around 2016 timeframe. It just started popping up everywhere in my world. So where I was working at the time, we were investigating solutions to build out our next generation data flow system. It was going to connect internal systems, bring data in from external third parties. And the way we were doing this wasn't going to scale. It wasn't very maintainable. So we were looking for a better solution to design our replacement on top of. NiFi came up then. It looked really powerful. Around the same time, I started hearing from other developers in my personal network, college, and various jobs. They'd all sort of ended up through, multiple hops at different companies. A lot of them had landed working on this Apache NiFi project, coincidentally. And one of these was Andy, and these were people who I knew really well. I knew they were good at what they were do. They certainly would not be hurting for opportunities in this industry. So the fact that they had all chosen to come work on this project really said a lot to me. So when the time came that I was looking for something new to do, I reached out to them and asked, what's going on with this Apache NiFi project? Do you have need for more help on it? And figured out how I could get involved. And it was a great choice. I love working on it.
And Andy, how did you get involved in the project?
So I was working on different problems, but I was sitting next to and good friends with a few of the early developers on NiFi. And so it was something I was tangentially aware of. And it really wasn't until my time out at Apple were doing large data flow problems and didn't have a tool like this. And so we were kind of building a lot of disparate systems internally. And then I kind of realized how important the visibility, the responsiveness, the resiliency, the detection aspects of data flow problem and inherently the solutions are, because other organizations just don't have access to this, or at the time didn't, and spent so much time and energy and resources trying to build their own system. So that was how I got, interested in the project. And then when the project was open sourced, I had an opportunity to join a startup that was working on it and had all of the original people who built the thing from scratch. And I turned it down because I wanted to stay in California instead of moving back to Maryland. And then 6 months later, I had an opportunity to join it again because they had been acquired by Hortonworks, and Hortonworks would allow me to stay in California. So I jumped at that, and that was almost 3 years ago.
And we've talked a little bit about some of the workflow and use cases for NiFi, but in your perspective, where do you see it sitting in the broader landscape of data tools, where you have on one end of the extreme some of these industrial strength systems that we talked about briefly, such as Spark or Flink or Kafka, where you're processing massive amounts of data at high velocity, and at maybe the other end of the extreme, you've got individual scripts or orchestration tools such as Luigi or Uzi or Airflow for being able to trigger various jobs in various external systems.
Yeah, so
that's a great question. Go ahead, Kev.
I definitely think so. One, NiFi is very mature. It was worked on and developed and hardened internally at NSA for a long time before it had its open source debut. So it's definitely battle tested, pretty mature, and that also comes with a ton of integration with these other systems, which make NiFi a really, really great complementary tool to a lot of the other systems you mentioned, the other data management and analytics and storage technologies that are out there, because if it has an API to write data to or read data from, or even if it doesn't, chances are NiFi can connect to it pretty easily using tools that are built into NiFi out of the box called processors. And so a lot of processors are adapters to other systems. And if one of the few hundred out of the box processors or community available processors doesn't do exactly what you need, NiFi is really extensible. So as Andy mentioned, NiFi is all about data in motion, data flowing. If you have a data platform that has one of these other systems in it, chances are you need to feed it with data or take its output and store that somewhere else. And NiFi is just a great, great tool to do that job for you.
And so in some ways, it seems like it is also sitting in a similar area to tools such as FluentD, which are intended to just be these sort of integration points between multiple systems and being able to route data, from one location to another.
I think how you view NiFi really depends on your experience and familiarity with other tools. So there are a lot of people who have used ETL systems, and that's how they see NiFi. And it's not really what it is, but that's the context that they have, so that's how they approach it. There are other people who have job or workflow orchestrator experiences. Some people have this enterprise serial bus. So we feel pretty strongly that NiFi is for moving data. It's not necessarily the backbone of your system. It's not a big storage lake for your analysis. It's not a complex event processor. There are a lot of things that it's not, but what it really is just a platform that should let you get the data from where it's generated as early as possible and put it into the locations that consumers, your other tools or other users need it to be, and in the format that it needs to be. So it does a lot of transformation, enrichment, filtering, prioritization, routing. It's really, like Kevin said, it's very extensible. We want it to be able to work with whatever offering you have so that you don't have to do the extra work on those source systems or the follow-on systems to get it into a different format when NiFi can do that for you. And then there's also a sub-project, Apache NiFi NiFi, which is designed to kind of extend your reach farther out into this giant data ecosystem so that you can collect and manage data earlier in the data lifecycle. NiFi is designed to take advantage of all of the resources that are available to it. So you put it onto a server or a cluster, and it's going to use all of that power. Whereas NiFi is designed to be a good neighbor. It it sits on some other system that's not intended to be running it, and it respects the other systems or software that's there. And so it's really good for embedded devices, IoT devices, things like that. It is available in both Java and C++. It's about 100, well, actually 1,000 times smaller than NiFi for the C++ version. And it doesn't have a user interface, but it still lets you do a lot of the small, data operations, and extends your visibility, your insight, and your decision-making capabilities much farther into that, weird ecosystem of lots of different data generators.
And so it sounds like maybe the best way to think about it is as a data integration framework with a high-level interface to allow for easy self-service by non-programmers.
Some people see it as a competitor for Kafka, and we really don't, because I can't tell you how many times we do a deployment and it integrates directly to Kafka, because that's the message bus that the user has chosen. So it works really well in conjunction. But Kafka, for example, like, you have to have these connectors. You have to, often write code to integrate that to your other system, or run a command line tool that's specifically built for another system. Whereas NiFi, ideally, you can just drag a box onto the canvas and it will work with whatever your other source or follow-on system is. So we try to make it as drag and drop easy as possible. And that UI, like you mentioned, is really helpful for that. But just to try and, like I said, lower the barrier of entry to getting all that data connected and flowing.
And the data that you're working with when you're building a NiFi workflow, is that primarily going to be routed through the same servers that NiFi is running on, or is it more of a system that is going to maybe trigger operations in other external systems, or is it more just a collection of both and dependent on whatever it is that you're trying to do?
Yeah, so that's a great question. Almost all of the data will flow through NiFi, through the NiFi systems. NiFi has the capability through either execute script processors or shell commands, or invoking HTTP endpoints to trigger operations on other systems. But that, again, kind of goes back to the job or workflow orchestrator role, which you can kind of force NiFi into that role, but there are other tools that are better for that. So NiFi is really more designed to be the steward of the data as it passes through the system, and move it from A to B, as opposed to telling some external system move it from A to B. Because that way you get the data provenance feature, you get the statistical analysis features, you get the auditing, you get reporting. All of those benefits come from NiFi being the one that moves the data itself.
Yeah, I will just add to that. The way NiFi reads and writes the data is through an abstraction. So NiFi has various repositories. The main bulk of data is the flow file content repository. So that's, the actual bits of the data flowing through the system. And that repository is an abstraction interface. So it's, even though data is on NiFi, it's on the same system that's running the NiFi server. That doesn't have to be, like a physical file system. It often is, but if you're doing a containerized or cloud-based deployments and you're in an ecosystem where your cloud vendor can present network storage as local storage, something like Kubernetes running in one of the major cloud vendors, that's a popular approach. So because we have these abstractions for the various repositories, it's pretty extensible in terms of what do I want to use as the storage of my architecture when I'm building out my infrastructure. So there's lots of ways you can configure something like a cloud-based deployment for how you're going to set up your data storage along with your data processing and make that all work together. And it will work with NiFi if you set it up correctly.
Yeah, I would also say, I know we're throwing a lot of terms around, and this sounds very complicated when it's nebulous and just ethereal in somebody's head. Go to nifi.apache.org and download it and start playing around with it, and a lot of this will will fall into place very quickly.
And on the point of the data provenance and tracking and monitoring features, those are definitely very valuable aspects of the system and things that are often secondary concerns of other tools or platforms that can be difficult to get right, particularly in terms of things like metadata tracking. So can you talk a bit about how that all integrates in the NiFi system and some of the reporting capabilities and alerting capabilities that are built on top of those?
Yeah, so Kevin mentioned the repositories that NiFi uses to store data. And like you said, the content repository stores the actual arbitrary bytes that you're operating on. It could be CSV or JSON text, it could be video or images or binary data, whatever it is, it's put into that repository. And there's basically a content claim, which is think of it like a C pointer. So it directs you to an address within that repository, but you just move that little pointer around throughout the system. You don't have to copy the data over and over when it's unnecessary. And then there's a flow file repository. So flow file is that unit of information. So it's a series of key value pairs, which we call attributes. And those are small and lightweight and kept in memory. So they're very fast and can be operated on at any time throughout the course of the life cycle of that flow file. And then it has the pointer to the data. And then there's a third repository called the provenance repository. Data provenance, the term comes from wine and art in history. It's being able to see the entire history of that piece of art or bottle of wine. But in this case, it's the data itself. So any operation that happens to that data, whether it's the flow file getting created at the beginning of the system, to it being routed based on some attribute and decision making there, to transformation, encryption, new attributes or attributes being modified, being sent to an external system, being viewed by a user in the user interface, every event that happens creates another record for the provenance of that item, that flow file. And so you can trace that. There's a very nice user interface for tracking the lineage of data, but you can also export that information into whatever format you want, and that gets stored in that provenance repository. So you can also then treat that provenance data as raw data anyway. So you could do things like send it into another NiFi flow and treat it just like you would treat any other data that you ingested from some external system. So it really allows you, you can export it to Apache Atlas for governance and tagging work. You could, do transformations and visualize it in something like Kibana. I had an intern a couple years ago actually who used the provenance data in a machine learning model and did like K nearest neighbor algorithm and analyzed not only the flow efficiency of various flows, but also could do anomaly detection and see things like early field failure for if hardware, the latency started changing on certain parts of the flow. There's all kinds of applications from that. As far as the reporting, NiFi comes out of the box with some reporting features. You can obviously send to email or Slack or other like reporting things like that. But you can also have memory consumption being reported on, CPU usage, all kinds of reporting things that hopefully make a DevOps person's life easier and integrate with whatever tool they're using to monitor their deployments as well.
And further on the point of the graphical UI being the primary means of interacting with the system, it can often be difficult to design that in such a way that it's both usable and flexible enough to be able to actually be useful in a broad context, because it's very easy to get stuck in the system of I just want something that's very easy for somebody to get started with, and then once they get to a certain level of capability, they start butting up against the limitations imposed by the UI. Or you can go to the other extreme where you have 1,000 knobs and dials and nobody ever understands how to actually get the thing to work, and so it ends up being worse than just not having a UI at all. So what are some of the approaches that you use to sort of balance between those extremes?
Yeah, great question, especially because I think when you're new to NiFi, when anyone is new to NiFi, the background that you have, where your strengths are going to color how you view it. So some people, they view the UI and the visual flow authorship, and that's great for them. They program when they have to, but they'd like to avoid it otherwise. Other people are very comfortable programming in many languages, have a long history of scripting things out, working from a command line in a console, completely text-based systems, and they're just more comfortable there. And the UI can be maybe a little bit of just unnecessary from the way they normally work, or it's even if it's not, once they start using it, they like it. It's great for getting started, but then it's not clear to them how this tool is going to work in their traditional workflow, which is code-based or text-based. It's a really exciting time right now for NiFi because I feel like it can actually span these types of ways of interacting with it really well. So it's great when you're new to it because it's a visual tool. It has a UI, documentation's right there. So while it does have a little bit of a learning curve, you can jump right in and start building flows that actually work, that actually do stuff. They accomplish the goal you set out to do without stumbling over things like syntax in a new DSL or language, that you're unfamiliar with. So it's great to get started with. And then when you are ready to do something like codify your data flow, move it from maybe your local laptop that you're developing and testing on into a production server, the tools in the ecosystem are there to help you do that very easily. So one recent subproject of NiFi called NiFi Registry is designed as an external and centralized storage location that handles flow definition storage, flow versioning, flow diffing. It integrates directly with NiFi and other tools in the ecosystem. So, think of it as, a code repository or an artifact repository like Nexus in Java, a place that when you're done with something, you can commit it or save it or mark it as a stable version of something you want to move somewhere else or have available as a copy later. And then over time, as you build up those versions, you have these snapshots that you can get back to any point in time. So you make a change, don't like it, you didn't, lose a known good state where you were at before. So NiFi combined with NiFi Registry is a really powerful combination. It makes NiFi really fun to use because it's so tightly integrated. So whenever I'm working on a flow, you can just right click, save a version, change a version, and then if you have two NiFi instances pointed to the same NiFi registry, you can easily, write from one NiFi and read from another one. So I can push up to a NiFi registry from my local development machine, my laptop, and then pull down that change on running server in another environment, whether that's a integration test environment, staging, production, what have you. So while NiFi is really approachable with a UI at first, once you want to do automated tasks, or something that's reproducible and reliable or more codified, it's all there under the hood. So, flows get saved in a few various formats that are used under the hood that are deterministic and completely specify your flow. So, there's an XML format that's used by NiFi. Registry stores in a JSON format. So there are ways to get your flow definition into something text-based. And then from there, there's lots of tools that you can use with NiFi and NiFi Registry. Both behind the UI have a very well documented and complete REST API that you can interact with. And there are lots of tools that interact with those APIs to make it even easier to get started with without calling the REST API directly. There's abstractions. One that's relatively new, came out around the same time as NiFi Registry. It's called NiFi CLI, and we can talk more about that. But it's a great way to start automating some of your operations work once you're using NiFi in a more traditional like enterprise or industrial environment.
As far as your question about balancing the UI between beginner and advanced, or people who want to use the UI versus other ways to control NiFi, I was going to say we have a great designer, Rob Moran, who basically anything you see in NiFi, he has done a ton of talking to users and making it easy. And then Matt Gilman and Scott Aslan are two of the developers who can translate those ideas into actual responsive user interfaces that people enjoy using, which is not a skill I ever picked up. So happy that they're on our team.
Yeah, I always say that I can make things work, I just can't make them pretty.
Yeah.
One of the questions I was about to ask as well is how you would manage something like a code review process that you would use with a typical software development life cycle, but if you're able to sort of export the data flows in these textual formats, then you could still use a lot of your standard tooling such as Git and GitHub or whatever it is that you might be using to version and codify these definitions and still put them through a code review process before then promoting them up to a production system. So that definitely adds a lot of value as well.
Yeah, so one of the tools I mentioned, NiFi Registry, it actually does have, like NiFi, it's very extensible, so you can configure various providers for certain internal interfaces. And for its persistence, you actually can configure it to use a Git repository with automatic syncing to a remote. So I can run a NiFi Registry instance, have it save every version of every flow as a commit to a Git repository that automatically gets pushed to a GitHub repository or something like that. So there's definitely ways to work with these tools that are available. What we're really trying to do is not dictate one workflow, but rather give you a set of tools that are maturing all the time that you can adapt to whatever workflow your team or organization is using. I found from my experience, it's a little bit different everywhere you go. So rather than being very opinionated about that, we're trying to give our users a set of tools that are flexible enough to integrate with however they want to use flows alongside their traditional SDLC.
And for people who are working on integration points or adding functionality to NiFi from external systems or building it into their existing platforms, what are some of those integration points that are available?
So out of the box, in version 1.7.0, which was just released at the end of June, NiFi comes with over 260 processors out of the box, and I think it's 48 controller services. So it's almost the case that you're going to have something immediately that you can work with. But let's say you're working with something like a proprietary format that your organization uses or some other custom thing that's not out there and NiFi doesn't have something for already. There's a few ways that you can integrate with that. NiFi has a very clearly defined framework and API, and then all these extension points. So, for example, writing a custom processor is a fairly easy task. There's a Maven archetype, which is available, so it gets you up and running, builds the skeleton of everything that you need, and you just have to populate one method, really. Maybe some validation if you want to as well. But you can also tighten that feedback cycle and use what we call an execute script processor, where you can just drop a script in Groovy, Ruby, Python, Lua, Clojure, or JavaScript into this execute script processor, and it will run, and it has access to all the context that a normal processor would have. So that will let you make, you can make changes directly to the code very, very quickly. All you have to do is stop, edit the script, and then start the processor again. So that's, on the order of magnitude of like seconds or minutes for a feedback loop, as opposed to writing a custom processor, writing unit tests for it, deploying it, building it, deploying it into a NiFi instance, restarting NiFi. Like that'll get you onto the minutes to an hour order of magnitude. So we recommend using the execute script to like prototype things and find the behavior that you want, and then codify that into a custom processor that you can deploy across all of your NiFi instances and have that functionality available for any user right away. There's also you can use NiFi to run a shell command and pipe input and output. So let's say you have this legacy system that somebody wrote this compiled library object 20 years ago, and you have no visibility into what it's doing inside, but it's this critical piece of infrastructure that everything has to go through. You can have a flow set up that's just delegating that portion of the work to that shell command and getting the feeding it input and getting output and keeping that into a flow that's managed. And you can have that running while in the meantime you might have a team trying to modernize that side by side. So there are really a lot of ways that you can, again, our goal is just to make NiFi easy to use the way that your system currently works and not have you have to re-architect your entire organization in order to adopt this tool, which isn't adding much if you have all that added cost.
And what are some of the use cases or project requirements that lend themselves well to being solved by NiFi?
As Andy mentioned, to introduce NiFi, it's a it's kind of designed to solve the generic data flow problem. I have data in motion. I want to manage how that, how that data flows, how it moves through my system. So it is really generic in that way. And what I would say is, even if you have a use case that might on paper or at first look like it has very simple requirements, and running something, as a server may feel overkill. You just have to do a simple load a file into a database. You can write it in any scripting language you're comfortable in. It's probably already on the Linux server. I would say chances are most projects' requirements do grow and change over time. So, reaching for a tool like NiFi, it's probably going to do whatever you need it to do. If it doesn't, it's extensible. And as your requirements change and grow over time, it's going to grow and scale with you, so that when you have a very large, complex data flow 6 to 18 months from now, the tool you started with is still very well suited for the job. That's all I have. I don't know if you want to add to that, Andy.
Yeah, I think that's a great answer as far as the actual like data requirements. I would say as far as like industries or use cases, we know that a lot of industries really are relying on far more data than ever before to do just their core functions. And so you have financial institutions that need to track transactions, and they want to add value and protect themselves by doing like fraud detection and pattern analysis. We have telecommunications customers, we have hospitals and healthcare providers who need to track all of their patient data really carefully. They need to integrate with legacy tracking systems and hardware devices. Oil and gas is a huge one, and it's ironically very similar to the original use case of NiFi, where you have all these distributed systems that are collecting massive amounts of like sensor data, and on a rig that can be life or death. I mean, everybody is familiar with like Deepwater Horizon and these cases where there's sensors and being able to have access to that data earlier on can literally save lives. And so with the oil rigs, they throw a computer out there and put NiFi on it. And Chris Herrera and a couple other people have like a case study where it saved them over 200% on their data transmission. They were able to prioritize and detect these kind of machine sensor data patterns much earlier, and it was great for them there. And then things that are IoT, NiFi and MiNiFi in conjunction, I think can absolutely, and I don't use this word frequently, but revolutionize IoT, because you have access to so much information. You can perform the necessary operations out at the edge. So there was one example with a connected car, and we put a chip into the car that had MiNiFi running and could do all of this data exfiltration and analysis and protection and prioritization literally on the car before it ever transmitted anything back. And it saved massive amounts of money because it could prioritize whether or not to use public Wi-Fi versus LTE. And LTE is, obviously available much more frequently, but much more expensive to transmit data over. So just so many circumstances where having insight into your data and being able to manage it efficiently opens up brand new possibilities that we may not even have considered yet. And that's why we want to make this available to people who are the domain experts, and they're the ones coming up with these really cool ideas and features. And this is just providing a platform to make it easier to do that.
And what are some of the signals that would suggest that NiFi is the wrong choice for a given project?
Yeah, sure. I mean, we definitely believe that in data flow, it's very unlikely in a lot of situations that one tool is going to solve everything for you. Chances are you're using a collection of different tools that work well together. So NiFi is great to work with those other tools, and there are definitely things, if you find yourself using NiFi for them, probably want to reconsider or avoid it in the first place. So that would include certain types of analytics. You can, I've seen plenty of data flows where people are doing some light analytic work just right in line with NiFi. But if you want to take, advantage of some more advanced analytic features with things like sliding data windows, within that window, I want to find a max or minimum or an average, like a rolling window over time. Like that's not built into NiFi. I wouldn't recommend using it for that. There are tools out there that do things like that, like Spark Streaming. So there's a lot of tools in this space that might, at a glance, look similar because they may even have a similar UI where you're building a directed graph of components on a canvas, or even if it's not visual, it's kind of text-based, has the same paradigm of I've got these processors and connections between them. But really under the hood, they have been designed to do things differently in terms of the trade-offs that they make and how they're optimized to work. So you really need to look at your domain and you need to think about what are the types of expensive operations I want to do, or what are some of the complex modeling or algorithm analytical work I need to do, and is the tool I'm reaching for designed well to handle that case, or will I be fighting the tool in order to make it do that over time? You have to be careful. One of the great things about NiFi is you don't have to just be tied to it. It's happy to send data out to other systems and read it back in that way. So it's a great complementary tool, even if it's not your core data analytic or data store technology.
And for somebody who's looking to get started with NiFi and deploy it in a production context, what are some of the considerations that they should have in mind as they're deploying and scaling the installation, and some of the system or network parameters that should be considered in the process?
So I would say, do you want the easy answer or the long answer? Because the easy answer is just pull Apache NiFi latest from Docker Hub, and you're good to go, and pull it a few more times if you need to scale. But the long answer is that there are a number of ways to deploy and to scale, and our container story is not as strong as we would even like it to be. So there's ongoing work for Docker and Kubernetes improvements to really get into that completely dynamic scaling. As far as clustering, we don't really recommend having more than 10 nodes in a cluster, which can be kind of different for people coming from, especially from like a Hadoop experience where you want to scale your cluster to be super huge. But that's because NiFi is doing data movement, data flow. So there's a lot of network communication that happens. And the processing itself, we found that a handful of nodes really is powerful enough to do the actual processing that most of these flows take into consideration. And overloading with too many nodes actually just increases the overhead. So yeah, if you have a cluster that's 4 or 5 machines and they all have a few cores, some RAM, and a good 10 gig network card, you're pretty much set up. You're at the level of a giant enterprise deployment of NiFi.
And what have you found to be some of the most interesting or unexpected or challenging aspects of building and maintaining the NiFi project and the associated community?
So I found in the year I've been working on the project, first of all, the community is great. Probably the best software development community I've ever been a part of or been involved with. Really helpful, lots of ways to ask questions and get questions answered. Everybody has a great attitude and is really helpful and welcoming. One of the things that has surprised me has just been from hearing people ask questions and describe their use case, like the complete breadth of various different uses people are employing NiFi. It's across industries, across use cases, everything from individual hobbyists and researchers all the way up to huge enterprises, just massive companies with massive data problems, tiny little flows with a few processors all the way up to thousands of processors on a canvas. So, that's a really challenging design problem when you're working on a tool and you're thinking about trade-offs. You have to consider all those different use cases. And, a lot of times it comes with, just allowing things to be configurable and flexible and choosing reasonable defaults.
Yeah, I think for me, there definitely been a number of challenges. One was just adapting to open source, coming from a career where everything was very, very closed source. It was quite the opposite. But it's like Kevin mentioned, there's so many different people and organizations using this that, on one day I have a meeting with an organization that is processing like 1 billion records a day using the equivalent of three laptops in a cluster. And then the next day I see something on Twitter where the Cincinnati Reds are using it for some of their stuff. And so it's like, it's so across the board. You get, somebody I follow on Twitter for their information security expertise just randomly said, oh, I had this system and it was down. I was doing log ingest, and NiFi was just magic. Like, it brought, everything was queued up, and when the system came back online, I didn't lose any data. Like, I can't imagine doing this without NiFi in the future. And they had no idea that, like, I was working on it and I was following them, and it was just really cool to see that it's actually helping people do really cool stuff across the board.
Yeah, and that brings up one of the other things that we didn't get into yet, and is the idea of recovery and resilience and maybe back pressure when you do have some of these failures or mutations or changes either in source or destination data stores. So I don't know if you want to just briefly discuss some of the capabilities and built-in techniques that you've used for addressing some of those situations.
Yeah, I can touch on it briefly. So one of the ones you mentioned, back pressure, this was one of the moments for me when I first started working with NiFi, when I realized, like, wow, this is a really full-featured, well thought out system that's really, it really understands the domain of this problem. So between processors, you can set connections on a given processor or connection. You can set a back pressure attribute, which is basically, how many things can be queued up to go into this input before it's considered full. And that's based on, what you've tuned to be the processing capabilities of this step of your data flow. And then that can propagate back throughout the upstream systems. And you can set various, essentially configurations for what to do when they start getting back pressure from the components they're feeding. So it can propagate back up to your queue, and ultimately you do have to make a choice what to do with your data, but NiFi gives you the ability to configure that and make, put the logic into your data flow such that, like, when a queue is full, what do you want to do with it? Do you want to set a time penalty to send it more data, or things such as that? So, and these are things that you don't have to necessarily always worry about right away. As I mentioned before, like, wherever possible, we try to configure NiFi out of the box so that it has reasonable defaults. So if you don't want to change these settings, you just leave them. But then the nice thing is, after your flow's been running for a while, or maybe your data size grows, or you make a change to it, like, those settings are there when you need them. So it's a tool that you don't need to fully understand it to get started with it. But then as you start digging into it, you realize, like, wow, I can just configure a few things and NiFi works the way I expect it to. I don't, something I approach and think this might be really complicated to solve actually might just be a couple settings on a couple components. And then the rest of the system responds to do what you want it to do.
And what are some of the new features or improvements or sort of broad ideas that you have planned for the future of NiFi?
That could be a whole new episode of the podcast. So our wiki has a feature roadmap, and that's kind of directed by the community. It's truly open source software. Anybody who, from Joe Witt, who's been created this and working on it every day for 15 years, to somebody who finds the wiki page tomorrow and wants to start contributing. It's a very meritocracy of ideas type approach, and we really do try to evaluate the quality of the idea itself and not where it's coming from. So there's all kinds of things that are going to be coming up. For myself, working on the security side of things, I have this idea for like a TLS auto secure feature where you just kind of set it and forget it, and NiFi will continually upgrade the Cypher suite selection and protocol version and all this kind of stuff based on Mozilla TLS Observatory data, so that it can keep you secure without you having to think about it on a daily basis. There's encrypted implementations of the various repositories. There's new encrypting attributes and recognizing some PII or PCI sensitive data and protecting that automatically. Kevin can talk about the new stuff that's coming with enhancements to NiFi Registry and NiFi. So
Yeah, like Andy said, there's so much that's possible in the future in NiFi. There's a huge amount of ideas and uh, JIRAs with feature proposals, things in the backlog and on the wiki. Um, it's one of the things that makes working on the project really exciting is just there's so much that is still left to do and can be done on it to make it even better. On the NiFi registry side, it's still relatively new sub-project, so there's a lot that can be done there. One of the ideas that we have right now is two things there. So one, making it so that a NiFi registry instance can be publicly hosted and shareable. So, analogy might be Maven Central or Nexus repository or Docker Hub for Docker images, but a place that people can collaborate and, push up data flows or parts of data flows, little modules of reusable sections. So NiFi, the term would be a process group where you can group a subset of your flow on a canvas inside an element. And then that now becomes something that you can save as an individual component up to a NiFi registry. So, enabling more features with NiFi registry to support this type of collaboration and sharing. It could just be something you run on-prem and just share amongst your team, or it could even be publicly hosted out on the internet where people can publish little reusable data flows that other people can pull down and do, that composite together a lot of steps that the simple processors do into something larger and more useful. Also on NiFi registry, just being able to store things other than flow. So we touched on earlier in the podcast the ability to write custom processors, and you can start a Java project to do that. The output of that is a NiFi archive format called a nar. So being able to version those artifacts in the same place you're versioning your data flows in a NiFi registry, and then with NiFi, the ability to pull them in and load them at runtime rather than installing them into NiFi's lib directory. So just, think about just making it more flexible. The analogy here would be like a package manager for other systems, but a central place that you can publish binary components that then a NiFi or MiNiFi instance running anywhere that's connected and has visibility to that can, look them up by ID and version number and pull them down and run them. So just making it more flexible with how you deploy these things, making parts of your NiFi data flow more modular and shareable. So this is going on the NiFi registry front. On the MiNiFi front, there's a ton of work being done right now on the MiNiFi C++ agent, which is an alternative to the Java one. It's designed to get you all the way down into really tiny footprints of memory and processing, really modular. So again, you can pick and choose the parts of it that you want. It's extensible, so you can run it on a device, on an IoT device, where you might have custom sensor or USB devices, peripherals, cameras, sensors, what have you, and the ability to integrate directly into that with just a tiny little MiNiFi agent that's running natively on the device and pulling all that data right on site, maybe doing some local processing with it there, or just tagging it with NiFi provenance data and sending it back to a central data center for the bulkier processing, which might be, sending it off to another NiFi instance, but getting the data provenance all right from the point of time it originated. So there's a ton going on with MiNiFi, NiFi registry. Andy and I can't speak to this much, but if you're into front-end development, one of the things that started there is NiFi Flow Design System, which is a Angular-based UI UX design system of reusable components that got started as it's really, just like a library for the front end work, so that we can start to put some of those UX and UI components in one place, the theming, the interaction as these reusable pieces that then we can use to make our interfaces across various systems like NiFi and NiFi registry more consistent. So if you're listening and you're a front-end developer and that sounds like your thing, like getting in on the ground floor of this awesome new design system that's going to be used in all these different NiFi tools we've been talking about, check it out. It's a sub repo. It's on GitHub or apache.org. Go to nifi.apache.org and you can read about how to get involved with all this stuff.
Yeah, the UI was actually something that when I left my previous employer to go work on this, one of the engineers looked at it and he came to me and goes, "Wow, I've been trying to do this user interface type stuff in my side project, and I've never been able to build something like this." He said, "I'm going to steal all your code." I was like, "Well, it's open source. I mean, you're able to you're able to use it, and hopefully, power whatever cool features and ideas somebody else has too."
So for anybody who wants to get in touch or follow the work that you're up to, I'll have you each add your preferred contact information to the show notes. And as the final question, from your perspective, what do you view as being the biggest gap in the tooling or technology for data management today?
Yeah, one thing that's a big challenge today is, as I mentioned, chances are if you have a real significant data problem that you're trying to solve with a tool like NiFi or the other tools that have been covered on your podcast, Tobias, chances are you might be using more than one of them, or you might be using one and then migrating to a different one. And, one of the rising challenges in this space is how do you deal with data governance and data lineage and applying the right policies, which might not be technical limitations, but might be policy limitations or regulatory limitations or law limitations to what you're allowed to do with data, if it can leave your country's borders or if it needs to be anonymized before doing that, right? It's a big topic right now with things like GDPR and a lot of attention being put on data utilization in technology. So while there are tools out there that are being developed and admirably trying to solve this problem, tools like Apache Atlas, which NiFi integrates, is one that's going after this problem. I think there's still, as the policies and regulations evolve, I think the tooling is going to have to catch up and stay current with being able to easily adhere to those sorts of things.
So the biggest gap that I see is, and this is 100% biased because this is what I deal with on a regular basis, but security. I still think that the fundamental approach to security is not as widespread and as strict as it needs to be, and security is often looked at as a bolt-on or a follow-on responsibility after the core work of getting data from X to Y or doing some analysis. And it's always too expensive to deal with it up front, but that's far, far cheaper than reacting to a breach or some other kind of incident. And as we see, I mean, just ever increasing each week, something's happening. So I think that, NiFi is a good start in that, but certainly there's room for NiFi to improve as well. And just to make it easier for users to have a secure deployment, because it's not fair to just keep saying, "Oh, the users didn't set this up," or "the users didn't take this into consideration," when the tools are not easily configured or available or understood. So I think that's a responsibility on, us, the creators and developers of these tools, is to make security so easy to use that there's no excuse not to. So that would be my answer.
Yeah, great point. I totally agree. And I also think that's a reason that if you're trying to solve these problems, there's an advantage to using community or industry accepted tool, something from open source or a vendor tool where somebody is solving this problem for you. Because if you try to solve all these problems yourself and build a solution yourself completely in-house, like unless you're a huge company with a huge, engineering team, chances are you're going to miss something. So you've got real advantages to trying to find a tool out there that is taking these considerations really seriously. That's a good point, Andy.
All right. Well, I want to thank the both of you very much for taking the time today to join me and discuss the work that you're doing on NiFi. It's definitely a very interesting project and one that I'm excited to see future development on. When I first came into this, I wasn't quite sure exactly what the platform was and what use cases it was targeting, so it's been very informative. So thank you both for that, and I hope you enjoy the rest of your evening.
Yeah, thanks for having us on the show.
Hey, thanks, Tobias. Really appreciated it.